Solving equations by adding and subtracting. This should be review for the past few years in math. So I'm just going to go over 4 different examples, refresh your memory, and that's all I'll have for this one. One of the key rules to remember whenever you're solving by addition and subtraction is to always add the opposite to the other, or add the inverse operation to the other side. That may not make sense, but hopefully it makes more sense whenever it's written out on paper. So the first one I want to give you is h minus 0.78 equals 2.65. Okay, this is a subtraction problem. That really means absolutely nothing. We want to get the variable by itself, so we're going to what's called isolate the variable. Sometimes I like to underline my variables or put them in a box so that way I know they need to stay put. They need to stay there. Only move them if I absolutely have to. So everything else needs to be moved over to the right-hand side of the equation. So in order to do that, the 0.78 is negative. There's a minus sign in front of it, so that means that it's a negative number. So to move that over, we do the opposite of the negative, which is to add. So I'm going to add 0.78 to both sides because it always has to stay balanced. Also, something to remember is when you cross the equal sign line, that's when we want to do the opposite operation. Okay, so after we've done that, our 0.78s cancel out on the left-hand side, and you're left with h. So we've got h equals, and then you add 2.65 plus 0.78, and you get 3.43. Always go back and check your answer. So we're going to plug this back in for h. And then you get 3.43 minus 0.78. And that should equal 6.25. 3.43 minus 0.78 equals 2.65. Okay? The next one is actually doing the opposite. Instead of adding to both sides, we're going to subtract. So for this one, your equation is 15 plus r equals 71. And again, to solve this, I want to make sure my variable is by itself. So I've underlined my variable to make sure that I know that's what I'm looking for. And everything else on this side with the variable needs to be moved over to the opposite side. So 15 here is positive, so to get rid of the positive, we want to subtract. When I subtract 71 minus 15, I get 56. Plug it back in to check. 15 plus 56 is 71. So it does check out in the end. 2 more examples for this one that I want to show you. This is when you have double negatives sitting next to each other, just to make sure you know how to maneuver those types of problems. The first one is b minus negative 65 equals 15. Okay, when in algebra, we throw in parentheses to close in negative numbers to show that it's separate from any minus signs or subtraction signs that may be thrown into the problem. But treat this just the way you would any other problem. Whenever we have two negatives next to each other, they essentially cancel each other out. So going back to your old integer rules, when you have negative negative, you just change it to add the opposite. So I'm going to actually take this problem and I'm going to change it to where I'm now adding the opposite. So now I can rewrite the problem and it should look like something that we just done. And then now that it looks like that, we have our variable on one side that we want to keep there. We want to move everything else over. So when we cross that line, we want to do the opposite sign. 65 is positive, so we want to subtract it. So then we have 15 minus 65 equals negative 50. Plug it in to make sure we did everything correctly. Negative 50 plus 65 should give me 15. And in the end, it checks out. One last problem just like that. In this case, the variable is one of our double negatives. So we have 18 minus negative f equals 91. Solve this one the exact same way as the problem that you just did. So because we have two negatives next to each other, we're going to cancel them out or add the opposite. So I'm going to change this problem and then rewrite it. Isolate my variable, make it by itself. In order to do that, I need to move stuff over. 18 is positive, so to get rid of it, we're going to subtract. (91) subtract 18 gives me 73. Plug it back in to make sure. (18 plus 73 does give me 91. And those check out at the end.